Hello guys, welcome back to my channel. So today we are going to learn about functions. So last time when we learned function, we saw that function don't return any value. For example, if we have a function and then we had z, it was simply print function hello user. So if we create now, Sammy, so if we see it does print, but if we want to take the output from this function, so if we want to have the output like x equals to greet Sammy, then print x, and we see that it prints nothing. So we don't want this. So usually the functions, as we had discussed last time, there can be multiple functions, and we have to create the function which returns. So now we will create a new function. Let's see. For example, this function is plus x comma y. It has an argument and then plus 1. Now I have a plus function. What I should do is that plus and then 3 comma 4. If you see, it is returning here. So this return statement helps us to return the function. So now if I want to save the variable x equals to or y equals to, since we are using Pluto, now I can print y, which will print the y statement. Now there is one more thing, like Julia automatically returns the last argument of the function. So if we have function add a and b, and if I just do a plus b, then this expression is already written. So we need to remember the last expression or variable is automatically returned by Julia. Now if we see here, what I will do, I'll do function, not function, I'll do add 10 comma 20. So we see here it is already returning. So if I do z equals to 10 comma 20 and then print z, so it is returning 30. Now one more thing is that, for example, we can use the subtract. If I want to show, for example, we can store the variable output and then it returns the output. So we can directly do x minus 5 and return output. This is also a way. So I'll do x and a equals to subtract 4 comma 3 and it is a 1. So the output is 1. So this is how it returns. Now another thing we want to see like is that how we can do a multiple return. So we can return multiples as well. So for example, if I have a function which is like powers, sorry for that, now, and if I want to return the multiple powers of 1, so 1, then I can return the power with 2, then power with 3, and then power with 4. Now if I pass in the powers, for example 2, you can see it is like this. It has written this multiple outputs in the form of tuple. So we should remember that it always returns in the form of tuple only. Now this is the first return, 2, 4, and then 8. So we can map it so in this way. Now, okay, I can show with, for example, this is the return. It will always return in the way we have pointed out. So the num will return in this way, and num to the power 2 is this one. So all the like whatever we have declared the in the like in the order will be maintained when we are returning. So this is one thing. Now another thing is that we can yeah, one more, let's have one more example. So for example, function circle, and if I pass radius, so I want to return parameter as well as perimeter. So area is 2 and then into pi and square. Perimeter is 2 pi r. So it's like 2 pi r square. It's pi r square, I think. Yeah, pi r square. So pi r square. Now if we want to return both area and perimeter, so what we can do, return area and comma perimeter, and this is how it works. So what I can do is circle with the area of 3. So it says r is not defined. So yeah, I have defined the argument as radius, but I have used here r only. So I will remove this one. You can see it has calculated 28.3 area and this one as parameter. So how to know, like since it is a tuple, so one number is this and the second number is this one. So this is how it is for the multiple returns. Now let's see if we want to pass in the like here what we are doing is that we are passing only one argument. But what if we want to pass multiple arguments? So we will learn about passing multiple arguments. So the best way like we can do is that we can write mm, our this function, one liner function, and we can print first. Let's see how to find the number of arguments. Now this is the simple function which calculates the number of arguments to the function. So if I have to write this function in function, so you can check like how to write this one liner function into function in my previous video. But here we are going to print the number of arguments. So now if I pass in the argument 1 comma 2, let's see, there are two arguments because one is this is first argument and this is second argument. But what if I do, for example, A and B, these are symbols 4. If I pass in tuple, so what happens? 5. So you can see that this is considered as one argument. This whole tuple is 1 and then this is 2, 3, 4 and 5. This is how we can see the number of argument. We can also like this is tuple destructuring. So this is one thing we should remember. So it is actually what it is doing. We are passing a tuple and it is destructuring that. So when an argument goes into the function, it is in the form of tuple. So we can just do test args. Let me do x and then I have destructured that. So I think this is the only way to passing the argument. So I can pass in the tuple. So arguments equals to 1, 2, 3, 1, 3, 2, and we can pass into an args. If we pass in args only, so it is argument 1 only because what we are doing here is that we are directly passing the this function args. But if we want to do, we have to like destructure it And if you see now, this is three arguments. So let's print the argument and see how it happens. So I'll write another function, test args, and we will again use this number of argument type. And here we will, instead of printing the length, our arguments are, let's see, now what if we do test args, and we will try to pass in the args itself. So we have this thing. So if you see here, arguments are, and if you see, this is passed in as one value because we are not destructuring it. So if we destructuring is like, if I have to say we are splitting this tuple into individual element, 132 into individual element. And what will happen is that if you see, this is converted into one element, so it has become three arguments. But if we don't use this destructuring, then it will be one single. So it is also expected in variables. So if I just print args, if you see, this is this way. If I use args and then this one, okay, it doesn't works here. So yeah, I can do, it works in function only. I can do restructuring this way, xyz. Let's use another thing, l m n equals to args. Now if you see this one, so what has happened here is that l has got a one value, m has got three value and two. So if I want to print this one, so I can just print l for this one, m, n. So if you see here, this we have destructured this. So this is how destructuring occurs. And in function, if we want to pass in, we have to use three dots in this case. So it will split the function, and this triple dot refers to the variable number of arguments. So that's one thing. So if you want to pass in the as many as argument, just try to use this triple dot and it should work. Now we will see about keyword arguments. What are keyword arguments in Julia? So the keyword arguments are, like, for example, this is very important to know that why we need keyword arguments. So we need keyword arguments because for example, when we are passing here, if you see here, we don't know what we are passing. We are passing in order, but sometimes in function we want to understand for what is the reason it isn't passed. So the main reason is that to use keyword argument, what I have seen is that it improves the readability of our code, like in function what we are using, and like flexibility how we want to, like for example, function with the argument. Let's see this one. So first of all, like I think we did work on circle. So here, like as we saw earlier, yeah? So here radius we were passing, but we were using r. So r is radius here, but we were using r in this case. And then hence we made a mistake of using r and radius, and we got confused. Similarly, like for example, if we want to do for rectangle, function rectangle, so area, I'll just make it function rectangle area, and I passing h comma w. Now what we'll do, we will return h into w. So now what will happen is here is that, so if we pass in rectangle area, called rectangle area function, we know this, but how can we should understand what is h and what is w? So here we are not referencing anything. And for example, even if I change this thing to height, and this thing to width. Okay. Now this function knows what is height and what is width. But here, like for example, we are not passing like what is height and what is width. So sometimes, for example, a developer has worked and he might do like for example, in this case, it will not be that kind of hard enough, but because like it might reverse the sequence, it might reverse the sequence, and then although the value is right, but like for example it will not be reflected in the function. Here we don't know what is height and what is but when we are passing, suppose this has converted into a module. I would like to take example of the module. So like this is a module and we have exported this module. Now when we are using this function, we really don't know like when to pass height and when to pass width. So in that case, keyword arguments become useful. So to write a keyword argument, we just need to use function. I'll use the small rectangle and then height, which will be float 64. So in keyword argument starts after semicolon. This we should remember. With float 64 and the height is float 64. Now what we'll do, return width into height. Now let's see, let's try to pass in the same thing we have done here. Instead of this function, we'll use the calculate criteria. So if you see no method matching criteria because we haven't passed it correctly. So now if I pass in width equals to and height equals to, then what happens? Let's see. Type error in keyword argument with expected float 64 and got a type of n64. Okay, so here is the thing, we can also use, for example, I think union, but this is not recommended actually. Let me try to see if it works or not. So now it is throwing height up, so I'll also do this thing to height as well. This is not recommended. We should use the abstract typing in Julia, which we will cover in next chapter, like in coming chapters. But yeah, um, that is better rather than using this. So for now, to temporarily solve the purpose, I'm using union. So this says that, for example, it will accept both union means float 64, a combination of float 64 or int 64. So now you see this is resolved, and in this case and here we see the difference is that here it becomes clear what is width and what is height we are passing to the function, but here the things are not clear, like what is the width and what is the height passing to the function. So this is the reason we should use keyword arguments here, and hence like it is very important to have this kind of work. So I would suggest always use keyword argument. This makes your function readable, your code more sophisticated, you are able to pass. And it is like always use int typing as well. This int is types of the argument, so this helps like your this whatever the linters are there, they are very good at passing this, and they can spot the like wrong code easily, so which might break. Now let's take another example just for the sake. Add numbers, and I will do this one as m64 and m64. So let's see how we do. If we do this one, yeah. So this is an example. If I do like this, add 2, 3, it works. But if I do x equals to 2 and y equals to 3, it will not work. The reason being is that whenever we are passing in like keyword argument, we should always use semicolon. So this is one thing which needs to be remembered. So if you're coming from Python background, then take this one with a grain of salt. But I think this makes more sense because it is helpful. Yeah, so to differentiate. What is happening here is that got unexpected keyword argument x and y. Okay, this is add. Let's add numbers. So yeah, so if I remove this semicolon, so it fails. So this is good actually because we know what is keyword argument. So keyword argument will always be after the semicolons. Now I can do more like on this. For example, greetings or like anything we can design more function. So let me see. I think we can let's take the how can we pass many keyword arguments. So instead of this one, so let's take the greet example first, and then we will go with the KW args in Julia. So this is as simple as like for this one. For example, do we can have like some kind of what do we say combination of both keyword arguments and this. So group person. So if I do string and then I am you after semicolon if I use here I'm using a keyword argument. Then println hello, then title and then name. So let's see what happens now. Greet person name equals to John Hawkins. No method matching greet person name equals to string. So this is because name is not a keyword argument. Now let's move this one to this. So now it has worked. Now if I try to add the title equals to yeah, so the title is default. So here how it shows how we can use the default argument. So whenever you use title and then like you can directly use the default parameters and then this should work. So and we can interchange the position as well. So for example, so I'll do Maria otherwise John will feel bad. So group person title equals to and what I can do here is that yeah, so this is how it works. We can also change the position, and this is very interesting because like it's like title is the default and the name we are passing without keyword argument. This we should remember. Now let's see the key KW args functionality. So as we saw the n args, like for example, args functionality, we can pass as many arguments with the help of triple dot. So if for keyword argument, we use KW args. So for example, let's see the function. Let me just okay. Now what I can do is that let's write a function which will greet a person and for example, you are designing app like in which wants to record the social media data of the user. So like there can be many information like name or place, and some information might be primary, like name and phone number is primary that you definitely need it, but other information can be there or cannot be there. So how can we record that? So let's see. And we have to use keyword arguments, so we can pass in as many as keyword arguments here with the help of triple dot. So now let's see what happens. We'll print the name, and let's since we know this is a part of dictionary, the keyword argument comes as dictionary. So I'll show you guys. So when you are using this keyword argument, try to use in this format. Don't use dollar keyword, otherwise it will print the main global variable name. And country. Now this ends. So I see some problem here. So can you guys spot the problem? Okay, this code is not right. This is right. Okay, and we end this function. So juxtapose string return. Okay, and this is wrong. We have to do this one. Now let's see. Yeah, it works. Yeah, try to see that when we are printing anything, try to use it rightly. Now, let me print. I can pass in person name without any keyword argument like Sammy, and then I can do age equals to 33, and then location equals to New York, and then profession equals to writer. So if you see, it has printed only two because we have got age and country as well. So I can add country, country equals to USA. Now, if you see whatever we have got is the age, we have name is by default printed because we are seeing name here, and other arguments are not necessary except name. So this keyword argument is like we can pass in any. So it has printed age and country. So if we want to print others, so let's see. I'll try to do print ln, and then I'll just print the keyword args. So this will reveal the information what it is. So if you see here, this is kind of a base pair symbol, and this is name tuple. So what happens is that when we pass in the keyword argument, those becomes name tuple. So we'll learn about name tuples later, but to access the name tuple, this is the way we can use it, because this becomes symbol. So if you see here, base pairs dot symbol. So to access that symbol, we have to use colon before, and then to access it. This is how it is. Now coming to the last part, what we'll do is that we will build the calculator. So using what we have learned with the help of keyword arguments and this the operation. So let me try to build it. Maybe you can pause and try to build the calculator by yourself, which takes add, subtract operation, multiply, generic operations. So we are using x arguments as number and y argument as number. This is the number type, default type, and we will use operation as a keyword argument, which is a symbol, and by default it will be add. So if you don't pass any value, it will be add, and we will be using verbosity to explain bool, and its default value will be false. So it is Julia, so I need to use small false. Now if operation equals to add, then result is, then we will return result as x plus 1. Okay, else if operation equals to subtract, then result is x minus 1. Else, okay, I need to use the Julius, so I am using Python else if operation equals to multiply, then result is x into y. Else if operation equals to division, then result is x by y. Else we can say that result is to supplied unknown operation. So in this case we are handling uh, a case scenario where we don't get any of the right value, operation value. Now we will just do if verbose equals to, if it is verbose, it's a boolean, so then we will get the operation as well. Okay, now we will return the result. Now let's see, let's perform the operation. So first operation we will perform is for addition, and will not, since it's a default argument, if you can see here, it's a default argument is add, so will not pass it and will not do verbosity. Will not. So you see it has worked. If I do verbose equals to true, then it will print the statement as well what it is doing. Now if you want to perform this as subtract as well, so we just need to pass operation equals to subtract and then multiply. If we want to multiply, and division if we want to divide. So here we haven't like seen, like one case we have forgot to add if the x is 0. So you see, or I think it should be if the denominator is 0. Yeah, but Julia automatically handles it for us as infinity. So we don't need to handle it by ourselves. So this is how we have built up a simple calculator in Julia within 2 minutes. So in next lesson we will be working on some other fun stuff. Thank you. Bye. Have a good day.